So welcome everyone to the video. In this video, we will be looking at circular motion and we will try to understand the variety of questions possible. What are the things that one must keep in mind when they're looking at the questions related to circular motion. Now, generally the questions which are asked are like two people are running around a circular track. If their speeds are given to you, then how many distinct points do they meet on the circle and things like that. So we will be looking at all these things with the help of one simple example. And going forward, we will be looking at other examples as well to express other concepts. Okay, so let's get started with this. So the first thing that we will be looking at is we will try to understand a few questions based on this data. So data, as you can see, it's pretty simple. Circumference of the entire track on which the two of them are running is 3000 meters. Speed of A is 25 meters per second and speed of B is 15 meters per second. What are the questions that we will be looking at? We will be looking at these questions with a condition that they are moving in the same direction, right? So keep that on your mind. Now let's understand the entire concept and how are we gonna look at this. So let me just draw a circle there. Yeah, fair. So both of them are moving in the same direction. When will they meet for the first time? This we will have to presume that they are starting at the same point, same time. So there's a person A, there's a person B. A is moving at 25 meters per second, B is moving at 15 meters per second. Now imagine about this, that after 1 second, what will be the distance between the two? After 1 second, the distance between the two will be 10 meters, right? A would have moved 25 meters, B would have moved 15. So the distance between the two would have been 10 meters at the end of the first second. It will become 20 meters at the end of 2 seconds. It will become 30 meters at the end of 3 seconds. So the distance between the two will keep on increasing at a rate of 10 meters per second. Now, when the distance between these two will become equal to the circumference of the circle, that's the first time that they'll meet. So when will be the first time that they'll meet? When the distance between the two will become equal to the circumference of the circle. In this particular case, that was 3000 meters. So the answer to the first question should be 3000. And this distance was created at a pace of what? 10 meters per second, which is nothing but the relative speed as what we have looked at in the last session, right? 25 minus 15, that will be 10. So when will they meet for the first time? They will meet after 300 seconds. That's the first question. Let's look at the second question. When will they meet for the first time? At the starting point. Now they have to meet at the starting point. Now let us understand, if they have to meet at the starting point, then both of them of course have to be at the starting point. Let's individually try and understand when does each one of them come back to their starting point. So when will A come back to the starting point? Time taken by A to come back to the starting point will be 3000 divided by 25. That would give you 25 ones are 25, 50 to 120 seconds, right? So time taken by A to come back to the starting point will be 120 seconds. Same way, time taken by B to come back to the starting point will be 3000 divided by 15. That will be 200 seconds. Now, please try and understand that A will keep coming back to the starting point at the end of every 120 seconds. That means 120, 240, 360, 480, so on and so forth, right? And same way, B will keep coming back to the starting point after 200 seconds, 400 seconds, 600 seconds, so on and so forth, correct? So effectively, if I take the LCM of 120, and 200, I should get a number at which both of them will be at the starting point, and that will be the first time they'll come back to the starting point. So let's try and get down there. That value will be nothing but 600 seconds. Now there are a couple of important points that we need to understand. One is when I'm saying that they're meeting after 300 seconds, that means they will keep meeting after 300 seconds. So they will meet at 300 seconds, they'll meet at 600 seconds, 900 seconds, so on and so forth, right? Second important point that I need to understand is once they meet at the starting point, from that particular point, the race will start all over again, isn't it? Can I say that? So when both of them are back to the starting point, can I comment that now race is starting all over again? Whatever happened before this, same thing will happen in the same sequence now, right? So after every 300 seconds, they will meet. And after every 600 seconds, they'll come back to the starting point. So the answer to question number 2 will be 600 seconds. How many distinct points do they meet on the circle? Now try and understand. At the end of 300 seconds, they'll meet. At the end of 600 seconds, they'll meet. At the end of 900 seconds, they'll meet. Now, the moment they meet at the starting point, after that, this will start repeating. So your first point will be a distinct point. Your second point is 600. which is 600 seconds, they are meeting at the starting point. So now once they have met at the starting point, this point of 900 seconds will be same as 300 seconds. So both these points will be same. And then of course the next point will be 1200, which will be same as the 600, which is nothing but the starting point, right? So effectively, what should I be doing? I should be looking at question number 2 divided by question number 1 as the answer for the question number 3. So that should be nothing but 600 divided by 300. That will be 2 distinct points on the circle. So the answer to this question will be 2, right? So that's the basic of things that we need to understand. Now on the next screen, what I'm going to try and do is I'm going to generalize a few things and derive a few results that you can directly apply. But it is very important and essential that you understand from where those logics are coming. Okay, so let's move on to the next screen and let's try and understand with a very generic data as to if there can be certain results that we can use wherever we want. Okay, so let's have a look at this generic data. So what I've done over here is circumference being L meters, speed of A being A meters per second, and speed of B being B meters per second. The questions remains the same, that they are moving in the same direction. When will they meet for the first time? When do they meet for the first time at the starting point? And how many distinct points do they meet on the circle? Let's try and understand this entire thing. Now, when will they meet for the first time? This question can be simply done by saying if they are moving in the same direction, the higher speed minus the lower speed will be their relative speed. So the answer to this question must be the circumference length divided by the difference of their speeds, A minus B, absolute difference between their speeds. That should be A minus B. When will they meet for the first time at the starting point? Once again, I'll take the LCM of their individual times to complete the circle. That's what we had done on the previous screen. Now, how much time it will take for A to complete one round? L by A. How much time it will take for B to complete one round? That will be L by B. Correct? If I take the LCM of these two numbers, then I should get my answer for the question number 2. Now, let us understand this is a fraction at this point in time. Okay. So how do I calculate the LCM of the fractions? I take the LCM of the numerator. So what will I get? I will get the LCM of the numerator, and in this case, numerator will remain the same for both of them. So LCM of the numerator will be nothing but L divided by HCF of A and B. Now HCF of A and B. So that will be the answer for your question number 2. How many distinct points do they meet on the circle? Now please understand. This we have seen. How many distinct points do they meet on the circle? How do I do that? I will take the value when they'll meet at the starting point and divide that value by the first time meeting, which will be the answer for your first question, correct? So that is what we are precisely trying to do. So let's do it in a generic format. What will we get? L divided by HCF of A and B. This value is divided by the value L divided by A minus B, correct? So let's divide this. So A minus B will go in the numerator and L will come in the denominator. L will get cancelled out. Now observe this very closely. What will happen? A minus B divided by HCF of A and B. Now understand this thing. Whatever may be the HCF of A and B, that will be present in A also and that will be present in B also. So when I'm doing A minus B, I can take that value common and there is an HCF in the denominator. So it will get cancelled out. Right? So effectively, whatever will be the values of A and B that you will be left with, they will be co-prime to each other. For example, if I say that the speeds are 15 and 20 meters per second, suppose these are the speeds. So what will be A minus B? A minus B will be 20 minus 15, correct? What will be the HCF of A and B? That will be 5, correct? So this will become 5 by 5. That will be nothing but 1. That is effectively nothing but the difference of their simplest ratio. So what is their simplest ratio of their speeds? 15:20. That will be 3:4, right? If you take 4 minus 3, that will give you the value 1. But remember this thing, you will attain this value only if the ratio is in the simplest form, because your HCF is there in the denominator. So that need to be cancelled before you get down to the number of points. And that will definitely be always present in A also and in B also. So that will get cancelled out. So if you bring down your ratio of speed to the simplest form, then I can very easily say that if they are moving in the same direction, they will meet at the absolute value of the difference of the two speeds in their simplest form. right? So 3:4 is the simplest form. So what is the difference over here? 4 minus 3, 1. So they will meet at one distinct points if they're one distinct point on the entire circle, if their speeds are 15 and 20, or the ratio of 3:4, whatever may be their speeds, right? So keep that on your mind, that you will have to bring down the speeds in their simplest ratio and then take the absolute difference of this value. You will get the number of distinct points. But once again, I'm repeating, keep that thing on your mind, that the ratio has to be of the simplest form. In this particular case, if you would have done 20 minus 15, you would have got 5, which is not the correct answer. So keep that on your mind, and then you can very easily apply and say that if they're moving in the same direction, take the ratio of their speeds to the simplest form, and then take the difference of these two values, will give you the number of distinct points where they meet on the circle, right? So let's move on. Same thing we will try to apply when they are moving in the opposite direction. Let's have a look at this. Once again, the same data, circumference being 3000, speed of A is 25 meters per second, and speed of B is 15 meters per second. Let me just draw a circle. Right. So A and B are starting from the same point, same time. And what are they saying? Saying when will they meet for the first time? Now they are moving in the opposite direction. So suppose A is moving in this direction and B is moving in this direction. Now, if A is moving in this direction and B is moving in this direction, then their initial distance between the two will be nothing but the entire value of circumference. That has to be reduced to 0 when they have to meet, isn't it? So when time was 0 second, the distance between the two was 3000 meters. When the time will be 1 second, the distance would have reduced by 40 meters, because A would have traveled 25 meters and B would have traveled 15 meters. So out of this 3000 meters, 40 meters would have been covered. So 2960 will be the leftover distance between the two. At the end of 2 seconds, what will be the distance left over between the two? 2920 meters, right? So effectively, what are we saying? They are coming closer to each other, right? So when will be the first time that they'll meet on the circle? That must be 3000 reduced at a pace of 40 meters per second, and that would probably turn out to be 3300 divided by 4, which is 75 seconds. So after 75 seconds, they will meet for the first time. Remember, whatever I taught you on the previous thing will also be applicable on this. That means they will keep meeting after every 75 seconds. So 75 seconds, 150, so on and so forth, they'll keep meeting at this same interval. When will be the first time that they meet at the starting point? Now, if they're moving in the clockwise direction or they're moving in the anti-clockwise direction, doesn't really make much of a difference to the time taken to complete the round individually, right? So how much time A will take to complete that round? A will still take 3000 divided by 25, which is 120 seconds. And B will still take 3000 divided by 15, which will be nothing but 200 seconds. The LCM of these two values will still be nothing but 600 seconds. So after 600 seconds, they will meet at the starting point again, right? What will be the answer for how many distinct points do they meet on the circle? Once again, when they meet at the starting point, the points will start repeating all over again, right? So 75, 600 must be divided by 75 to get down to the number of distinct points. So 15 5s are 75, 15 4s are 60, and 8 distinct points. So that's a generic method of looking at the problem when they are moving in the opposite direction. I hope you all are clear. Once again, with this as well, we will try to do the same thing, that we will, apply it in a generic format and try to derive a result out of that. Okay, so let's try and do that. Right. So that's my generic data once again. If L is the circumference of the circle, A meters per second is the speed of one of them, and B meters per second is the speed of the second. When will they meet for the first time? Now they're moving in the opposite direction. Okay. So when will they meet for the first time? L divided by A plus B, isn't it? Because they're moving in the opposite direction. So their relative speed will be nothing but the sum of the two speeds. When will they meet for the first time at the starting point? Once again, that will be nothing but LCM of the values of L by A and L by B. Now, what will be that? The numerator is same. So the LCM of the numerator will still be L divided by HCF of A and B. Now, how many distinct points do they meet on the circle? Once again, question number 2 will be divided. The solution for question number 2, or rather the answer of question number 2, will be divided by the answer of question number 1 to get down to the answer for question number 3, right? What is the answer for question number 2? That is L divided by HCF of A and B divided by the first answer. That will make A plus B come in the numerator and L will come in the denominator. So what will we be left with? We will say A plus B divided by HCF of A and B. Okay. Now, once again, HCF of A and B will be contained in A also, will be contained in B also. So that will get cancelled out. So if you bring down your speed to this speed ratio to its simplest form, then the sum of those two values will give you the number of distinct points. For example, if the speed is 15 meters per second and 20 meters per second, then what will be the ratio? 3:4. If they're moving in the opposite direction, then they will meet at 7 distinct points. You can apply that result directly. And that is something that you can very easily see over here. I really insist that each one of you sit at home and try and generate this for yourself. Once you've generated it for yourself, then you will not be required to remember all this, because that will stay on your mind automatically. Don't take it as a result that I have given it to you. Evaluate on your own, get down to the result on your own, and then you will realize that it works really, really well for you. I hope we all are clear with this, right? Fair. Now let's understand one more very important aspect of the entire circular motion, and then we will move on to the next set of questions. Okay. So the important aspect that I want you to keep on your mind is whether they are moving in the same direction or they are moving in the opposite direction. There's something that will remain constant. Once, suppose they're starting at this point and they're moving in the same direction. So in this direction, they've met after traveling a certain distance over here. Let's call that distance as X. Now they've met over here. Now let us be very clear about it, that from this point, once again in the clockwise direction, I will take X meters of distance, and that is where they will keep meeting. So between the two consecutive meeting points, the distance will always remain the same, right? The distance traveled will always remain the same. So effectively what happens is the entire circle gets divided into equal parts as that of the number of points that they're meeting, right? So suppose if they're meeting at 7 distinct points, so then the entire circle will be divided into 7 equal parts. So let me just try and put that 7 equal parts over there. So you already know how do we calculate the number of distinct points where they meet on the circle. We have just done that on the previous screen, wherein we have looked at both of them moving in the same direction as well as in the opposite direction. Now suppose I say that they're meeting at 7 distinct points. So what will you do? You will divide this entire circle into 7 equal parts. So this will divide it in 1, 2, 3, 4, 5, 6, and that will become 7. So 7 distinct points, 1, 2, 3, 4, 5, 6, and 7. Correct. So you have divided your entire circle into 7 distinct, seven similar length parts, right? Now another very important thing that you need to understand, whether they are moving in the same direction or in the opposite direction does not really make much of a difference. The number of distinct meeting points will be same as this division. Okay, so that's one. But keep one thing on your mind, that when you are this is your starting point, suppose, then it is not necessary that they will meet at the first point for the first time. It may happen that they meet over here for the first time, and then they will take two more round, then they will meet over here, then they will meet over here, and things like that, right? So it is not necessary that the parts that you have divided into, so their first meeting happens over here and second meeting happens over here, third meeting happens over here. That's not necessary, right? And eventually when we will be getting into the question, you will realize that that's not necessary. Okay, but keep that on your mind. So two things that we have spoken about on this particular screen. We have said that the number of distinct points that they meet on the circle, you can divide the entire circle into that many equal parts, and those will be the points where they will be meeting. Whether they are moving in the opposite direction or same direction does not really matter. This thing remains the same. Okay. The second important thing is, it is not necessary that if you're moving in the clockwise or anti-clockwise direction, your first point will turn out to be the actual first meeting point. No, that's not necessary, right? So let me remove this and let's move on to the question. Once again, we will keep the drill to be same, that I'm going to give you a certain amount of time to do the questions. Questions will not look really difficult, but will ensure that you settle down with the concept of circular motion, right? So let's get started with the first question for the day. That's your first question. Quick 1 minute of time. Try this out. Last 25 seconds. It's not a difficult question at all. We've done very similar question. It's just a practice of that. Last 15. Right. So let's have a look at this. A and B are running in the same direction along a circular track of length 3000 meters. A is running with a speed of 15 meters per second and B is running with a speed of 50 meters per second. When will they meet for the first time? Remember, they are moving in the same direction. So the relative speed in this particular case will turn out to be 35 meters per second. So the distance will start increasing at a pace of 35 meters per second. When that distance becomes equal to 3000 meters, that is the time they meet for the first time. So for the first part of it, which is part A, what will be the answer? Answer will be 3000 divided by 35. That effectively nothing but 600 by 7. So that is the time that they will take for them to meet for the first time. Let's look at the second question. When will they meet for the first time at the starting point? Take the LCM of the times in which they are completing their individual rounds. So 3000 divided by 15, that will be nothing but 200 seconds. And what will be the second case? Second case will be 3000 divided by 50. That will be nothing but 60 seconds. So 60 and 200, what will be the LCM of this? LCM of these two numbers will be 600 seconds. So after 600 seconds, they will be at the starting point. How many distinct points do they meet on the circle? The number of distinct points will be nothing but 600 divided by 600 by 7. That will be nothing but 7 distinct points. Now, this 7 distinct points you could have reached out to just by looking at the ratio as well. So what is the ratio? 50 is to 15 that you are looking at. Bring it down to the simplest form. 10 is to 3. Take the difference of these two as they are moving in the same direction. So 10 minus 3 would have given you the 7 distinct points. So you don't even have to look at the first answer and the second answer. If they have directly asked you the third question, then go ahead and mark the answer for the third question directly, right? Let's remove this and let's move on to the next question. Right, so that's your next question. Once again, a 1 minute time. Try this out. By race, what we mean is one complete round. Last 30 seconds. Last 15. Not a difficult question at all. Right. So it says two-person A and B are running along a circular track in the same direction. A is 4 times as fast as B. So A and B, A is 4 times as fast as B. So suppose B was moving at a certain speed X, then A will be moving at a speed of 4X. And meets B after 5 minutes for the first time after the start. So first time meeting is happening after 5 minutes. The length of the track is 1000 meters. If they are moving in the same direction, then when will be their first time meeting? 1000 divided by 4x minus x. Correct? That will be their relative speed because they are moving in the same direction. So what will happen? 1000 by 3x. That value is given to me as 5 minutes. Right? So what will be the value of x? X in that case would then turn out to be 200 by 3. Now remember this thing, this distance was in meters and this 5 was in minutes. So effectively what am I getting as the unit of this? 5 meters per minute. Okay. Now find the time taken by A to finish the race. A's speed is nothing but 4x. So that will be nothing but 4 into 200 by 3. And the entire distance that need to be covered is 1000. So that will be the time taken by A to complete the entire circle once, right? So that will turn out to be 205, 15 by 4 minutes. Once again, please keep that on your mind. Sometimes you get confused during the paper. They will give you 15 by 4 as minutes as well. They'll give you 15 by 4 as in seconds as well. And then, sometimes we in a hurry mark a wrong answer. Please be very careful with that. So 15 by 4 minutes will be the correct answer for this question. I hope you all are clear with this. Let's move on. Not a difficult question at all. So let's have a look at the third question. Try this out. Once again, a minute's time, not difficult ones. Try this out. Which of the following cannot be the value of x? Last 15. Right. So let's have a look at this. The seventh meeting is same as the first meeting. A and B are running along a circular direction, circular track in the same direction. The seventh meeting point is same as the first meeting point. Now, let's try and have a look at this. They're moving in the same direction and first meeting point is same as the seventh meeting point. When that can happen? That can happen when the number of distinct points are just one on the circle where they meet. So the seventh point will be same as the first point. That can happen when the number of distinct points on the circle where they are meeting are two distinct points. So what will happen? Second point will be same, first and the second two distinct points. So the third point will be same as the first point, fourth point will be same as the second point. So sixth point will be same as the second point once again. So seventh point will be same as the first point. So if they are meeting at two distinct points on the circle, then also the seventh meeting point will be same as the first meeting point. Suppose they are meeting at three distinct points on the circle, then sixth meeting point will be same as the third meeting point, and then the seventh meeting point will be same as the first meeting point, right? In that case also, you will have the seventh meeting point same as the first meeting point, or they've got six distinct points on the circle where they're meeting, and hence the seventh point will be same as the first point. Which of the following cannot be the value of x? Now understand this thing, x is to 1 is the ratio. So, and they are moving in the same direction. If I take the absolute distance or difference of these two values, that should give me the number of distinct points. If my number of distinct points is any one of these four values, then I'm fine with that. If that is not the case, then I'm not fine with that, and that value cannot be the answer. So 2 is to 1. First value is 2 is to 1. What is the absolute distance difference? That is 1 unit, 2 minus 1. So how many distinct points will they meet on the circle? 1, and that is allowed. Take the second value of x, 3 is to 1. So what will be the difference? 3 minus 1, that will be 2. So there will be two distinct points where they are meeting on the circle. And in that case, seventh point will be same as the first point. So that is also acceptable. 4 is to 1. What will be the difference? 4 minus 1, that will be 3, right? 4 minus 1, that will be what? 3. So they will be meeting at three distinct points. That is again an acceptable value. Look at the last one. 5 is to 1. 5 is to 1 would mean what? 5 minus 1, that is nothing but 4 distinct points. Now, if they're meeting at 4 distinct points, then your seventh point will not be same as the first point. Your ninth point will be same as the first point, right? So keep that on your mind, and hence, which of the values will not be possible? Option D, 5 will not be a possible value of x. I hope we all are clear. Let's move on to the next question. That's question number 4 for you. Try this out. Take a minute's time. Last 25 seconds. Take 10 seconds more. Keep trying. Right, so let's have a look at this question. It says that A and B are running in the same direction along a circular track. The distance between any two consecutive meeting points is 300 meters and track length is 2000 meters. Okay, then how many distinct points do they meet on the circle? Now, if the track length is 2000 meters, now think about it. This is your entire track and you are saying it is of 2000 meters. So at the end of 300 meters, they will be meeting for the first time. At the end of 600 meters, they will be meeting for the second time. Then 900 meters, they will be meeting for the third time, so on and so forth, right? Now, of course, your 2000 is not a multiple of 300. That means once they come back over here, they will have to jump and will meet somewhere in between these 2 points as well, right? So what will happen in this case is, suppose they're meeting at n distinct points on the circle. 300 into n, for every between any two meeting points, there is a distance of 300 meters, correct? 300 into the number of distinct meeting points should be equal to, because your last meeting point will be the starting point. Post that, the points will start repeating, correct? So 300 into the number of distinct meeting points must be an integral multiple of 2000, and the least integral value of k is something that will be helpful for us, right? So let's understand this thing. N should be, n is the number of distinct points, okay? So n will be nothing but k into 2000 divided by 300. This will get cancelled out over here. So now what should be the value of k such that n turns out to be an integer? You can't have 2.5 meeting points, right? So either you will have 2 meeting points or 3 meeting points, right? So the value of n has to be an integer. For that to happen, k must be equal to 3, the lowest value of k that I'm talking about, because then it will keep on repeating if I don't take the lowest value at this value for k. So k must be equal to 3. Now, if k is equal to 3, then in that case, the number of distinct meeting points on the circle will be 200. And this is what I was saying, that your first meeting point over here, you will divide this now into 20 different parts. That means every part will be of 100 meter. But first meeting was after 300 meters. So there will be a point over here, there will be a point over here. But this point will be their first meeting point. Third point will be their first meeting point. So just give me a second, I'll better clarify this. This is the value m1. Now this is the point 1, this is the point 2, this is the point 3. If I divide the entire circle into 100 meters part and 20 equal parts, so this will be fourth, this will be fifth point, this will be 6 point, 7 point, 8 point, so on and so forth. So what will happen? Third will be the meeting point number 1. This will be the meeting point number 2. Now this will jump, and sometimes 1 will also become the meeting point, right? So that is what I was trying to say, that if this is your starting point, then it is not necessary that this first division will correspond to the first meeting point. Your first meeting point can be at some other division as well. Keep that on your mind, and that will really help you on a lot of questions. Okay. So in this particular case, how many distinct points were they meeting on the circle? They were meeting on 20 distinct points. Try the next question. So that's your next question on the screen. It would take not more than a minute. Try this out. Last 30. Remember, they are moving in the opposite direction. Last 15. Right. Let's have a look at this question. It says that A and B are running along a circular track in the opposite direction. So if they're running in the opposite direction and A is to B is the ratio of their speeds, in the simplest form, then the number of distinct points that they will be meeting on will be A plus B. We have discussed this thing at the beginning of the session. How many distinct points are they meeting on? So A plus B must be equal to 8. B is moving with a speed of 15 meters per second. So I know this value, actual value is 15, and this value is X given to us. And A is moving with a speed of X meters per second. X is an integer less than 15. So this value is less than 15. Find the value of X. Now, please understand, in the present format, if the value of B is 15, and if the value of X has got no common factor with 15, then the number of distinct points where they meet will be more than 15, because it will become 15 plus X, right? That is something that I don't want. I want it to be 8. Right? That means the actual value X over here will definitely have some common factor with 15. What are the factors of 15? Factors of 15 are 1, 3, 5, and 15. So effectively, if I take 1 as the common factor, then that does not make sense. Okay. Because that will not be cancelling 15 at all, and it will remain that. So 15 plus something will make it, of course, more than 15 distinct points. So if 3 is the common factor between the two of them, then what are the possible values of X? The possible values of X are 3, 6, 9, 12, and 15. So if I take 3 to 15 as the ratio, will the simplest form give you 8 as the number? No, it will be 1 to 5. It will not give me. 6 is to 15. So 3 2s are 6 and 3 5s are 15. Again, 7 will not give me that. 9 is to 15. What is 9 is to 15? 3 3s are 9, 3 5s are 15. That is giving me 8 in the simplest form when you add A and B. So 9 will be an acceptable value for me. Let's check if there are any other values that are there with me. So 3 4s are 12 and 3 5s are 15. Of course, this is going beyond 8, and 15 is to 15 again is giving me 2 distinct points where they are meeting. So that is again not an acceptable value. So with 3 as a common factor, I've got down to my answer, which is 9. Can I take 5 as my common factor and then try and do this? So 5 is to 15. I'm just checking this out. We have already got the answer. So that's still fair, but we need to understand that the process is foolproof. So you don't really have to be bothered about it. 10 is to 15 and 15 is to 15. These are the only possible values when 5 is the common factor and X has to be necessarily less than 15. So this is anyways knocked off. This is 1 is to 3, again not a possible value. This will be 2 is to 3, again not a possible value, because you will not get the sum as 8, and 15 as a factor does not really make any sense, right? So the value of X will be nothing but 9 meters per second, and that is when this condition will be satisfied. I hope we all are clear with this. Let me remove this and let's move on to the next question. Right, so try this question out. Once again, a minute's time. Last 10. I'll still give you 10 more seconds. Keep trying. Right. Let's have a look at this. A and B are running in the opposite direction along a circular track of length 1000 meters. Speed of A is 10 and speed of B is 15. Now understand this thing, speed of A and speed of B is given to you. So you can then look at the ratio very clearly as 10 is to 15, which is nothing but 2 is to 3. So how many distinct points will they be moving on the circle? If they are moving in the opposite direction, that will be 5 distinct points. That means your entire circle must be divided into 5 equal parts. Right? So let me draw a circle over there and divide it into 5 equal parts. So your starting point is this, your first part, second part, third part, fourth part, and fifth part, right? So each of these parts will be of equal length that you are looking at. So 1000 divided by 5 will be nothing but 200 meters. So the first part will be 200, then again 200, 200, 200, and that will, this is, let's say, suppose is the starting point, right? Speed of A is 10 meters per second. Speed of B is 15 meters per second. What is the shortest distance between the starting point and the point where they're meeting for the 43rd time? Now, as I have told you earlier as well, that it is not necessary that if this is the starting point, then this happens to be your first meeting point. Don't make that mistake. Please check it out. So what is the ratio? 2:3. So when A would have traveled 2 parts, B would have traveled 3 parts. Now suppose A was moving in this direction and B was moving in this direction. So this is the direction for B and this is the direction for A, right? So A is moving in this direction and B is moving in this direction. When A would have traveled 2 parts, B would have traveled 3 parts. So when A would travel 2 parts, B would have traveled 3 parts and would have come over here. That means your first meeting point will be this point, correct? Your second meeting point will be this point. Your third meeting point will again be 2 parts from here. So this will be the third meeting point. What will be the fourth meeting point? Again, 2 parts from this place. So M4 will be your fourth meeting point. And then take 2 parts from here. M5 will be the next meeting point, which will be the starting point. Now, after this, M1 will repeat once again, right? So this is how it is going to move in this entire circle. Now, what is that they're saying? 43rd time. So there are 5 distinct points. So 43 divided by 5, you will get a remainder of 3. So basically they are talking about the third meeting point. So your first meeting point is over here. Your second meeting point is over here. Your third meeting point is over here, which will be your 43rd meeting point as well. And what is the shortest distance from the starting point? That's 200 meters, right? Be very careful. I've been saying this right from the very beginning of the session, that right after the starting point, this particular point need not to be your first meeting point. This can be some other meeting point as well. Okay, so please be very watchful about that. Let me remove this and let's try question number 7th. Now try this question out. This is going to take a little time, so I'm going to give you 1.5 minutes to try this out. Slightly tricky, think about it. Last 30 seconds. Last 10. Find the number of distinct track lengths possible. Right, so time is up. Let's have a look at this particular thing. Now, there are few hints always, of course, available on the question. You can call them hints, you can call them the data available, whatever that may be. Okay. So 2 people are racing along a circular track and such that their first meeting point is same as the 11th meeting point. Now, how many distinct ways can that happen? Now, the shorter distance between the starting point and the first meeting point is 300 meters. That means your starting point cannot be the only meeting point. So there will be more than one meeting points on this entire track, because if the shorter length has to be 300 meters, then there will be a longer length as well, right? So let's have a look at this. So how many distinct points can you have on the circle? You can have 2 distinct points. That is when your 11th point will be same as the first point. We have done this on the previous questions as well. If you have 5 distinct points, meeting points on the circle, then your 10th meeting point will be same as the 5th meeting point, which will be your starting point. And then 11th will be same as the first meeting point. That is also possible. Third thing which is possible is you may have 10 distinct meeting points on the circle, and hence the 11th point will be same as the first point. right? Now they are saying that the shorter distance between the starting point and the first meeting point is 300 meters. Find the number of distinct track lengths possible. Let's have a look at a few tracks. So if this is the track, and I say there are two distinct points, two distinct meeting points, and the first meeting point is at the end of 300 meters, and then the second meeting point is at the starting point, right? In that case, the length of the track must be 600 meters. There's no other way out. So you will have 300 at the midpoint, and then you will have another 300 and meet at the starting point. So 600 meters can be one of the track lengths possible, right? Now, let's look at the second case. If they have got 5 distinct meeting points, so suppose this is your starting point. Suppose this is your starting point. First thing that can happen is you may have each of these length as 300 meters and you have 5 distinct points. So 300, at 300 they meet for the first time, then at 600, then at 900, then at 1200, and then at 1500. So what can be the track length? It can be 1500 meters, right? But it may happen that this is not the first point where they are meeting. So this is 300-meter mark, okay? And this might not be your first division. There can be a division more in between. So suppose there is one more division in between. So this is your one division. Of course, these two lengths must be same. So this is 150 meters. This is the division at 150 meters. And how many distinct points am I looking at? I'm looking at 5 distinct points. So if one of this length is 150, then the total length can be 150 into 5, which is 750 meters. That is also possible, right? Now let's go ahead and look at if there is one more meeting point in between the two, and I'm still sticking to 5 distinct meeting points. Okay, so let me remove this 150 mark, and now you are dividing it into how many parts? 3 parts. So this will become 100, this will become 200, but I'm sticking to 5 distinct meeting points. So how many points I already have? I have 4 meeting points, and then one more will be there, 400, and then this will be at a 500 meeting point. Then in that case, the shorter distance to the first meeting point cannot be 300, because in that case, the shorter distance would come out from here, and that will become 200 meters. And hence you can't call the shorter distance to be 300 meters, and hence 500 cannot be the point. Now, if you divide this further with 5 distinct meeting points, then that does not make sense. So you will have to drop that 5 meeting points over here. If there are 5 distinct meeting points, and these are the only 2 track lengths possible. Now let's look at another circle wherein you have got 10 distinct meeting points available. Now, if you are meeting at 10 distinct points, and this is your first point, this is your starting point, okay? And suppose I say the first meeting point right after this is the first one. So this is 300 meters. So the next is at 600 meters, next is at 900 meters, and comfortably I'm able to complete that. So that can be one of the part will be 300 meters. So there will be 10 different parts. So that can be 3000 meters as one of the distinct track lengths possible. Now it is not necessary that this is the first point and that division is 300 meters. So let me take one more division in between that can be 150. Now, if that division is 150, then one of the divisions is 150, right? If one of the divisions is 150, then there will be 10 such divisions. So 1500, that length has been already counted over here, right? So we will have to drop that. So let me remove this. You will have to do these iterations to be very clear on your mind. So suppose there are 2 points in between. So if there are 2 points in between, then you will say that, of course, these points have to be equidistant from each other. So I've divided it into 3 parts. So each of these points will be of 100 meters exactly. So 100 into 10 will become 1000 meters. So that is one more track length which is possible, which is 1000 meters, correct? Now, this 100 is gone. So let me now have 3 points in between these 2 points. So let me remove this and let me take 3 points. So if I take 1, 2, and 3 distinct points over here, so I've basically divided from 0 to 300 into 4 equal parts. So one of the parts will be 75. If one of the parts is 75 multiplied by 10, that will become 750. That has already been counted. So once again, we don't have any further thing to do on this once I've divided it into 3 parts. So let me now divide this into 5 parts. So 4 parts we had divided. Now we will divide it into 5 parts. So we will basically require 1, 2, 3, and 4. So you will have 5 distinct parts. So 300 divided by 5 distinct parts. So each of these parts will be 60. Now, if each of these parts is 60 and you have got 10 distinct points, so that will make it 600. That length has also been counted. Let's go further. If you have 6 points over here, then what will happen? Sorry, just give me a second. Right. So suppose you are dividing it into 6 parts now. So you will require 5. 1, 2, 3, 4, and 6. So I've divided into 6 parts. So if I divide this into 6 parts, 300 divided by 6, one of the parts will be 50. So 10 parts will be 500. Now this is not possible. Why is this not possible? Because the total length is 500. Then no point can be having the shortest distance as 300, because that's not possible. The other side will become shorter than 300. So you can't call 300 as your shorter distance, and hence no further division will be acceptable. So there will be how many distinct track lengths possible? 5 distinct track lengths possible. A bit of hit and trial, but I think that's the best way to look at the entire thing, right? So if you hold on to these concepts, I don't really think that you will find questions which will trouble you out there. As I said at the beginning of the class, whatever concepts I've given you, try and evolve those concepts, come down to those concepts on your own, and satisfy yourself before you start applying them on the question. That's the best way to ensure that you don't make mistakes during the paper. So don't take my words that if they're moving in the same direction, I have to take the simplest ratio and then take the difference. Apply it on your own, see how do you get down there. That may take a couple of hours time, fair enough, give it. But for the rest of your time of preparation, you will not be troubled by any of the circular motion questions, right? So that brings me to the closure of the session, guys. So if this is your first session, then please go to the description of this video, and if you can be a part of our 100 days to CAT series. Do like the video and do subscribe the channel, and stay tuned for further sessions as well. Thank you so much. That's about it from my side.